All right, good afternoon, and thank you for joining my session. I'm Sagar, and I'm going to talk about benchmark testing today. Well, in today's dynamic world of Android app development, it's crucial for all of us to improve the performance of our app and provide a seamless user experience. But having a framework to measure the performance of your app can be a really daunting task if you really don't know where to start with. So I'm going to talk about how Google already provides a framework out of the box that comes bundled with Android Development Kit. And I don't see much of exciting things going on in the community related to this area, so that's why I selected this particular talk. And by the end of this talk, you would be seeing how it is easy to get started in measuring your performance metric in your local dev environment. So first thing first, who am I? I'm Sagar. I'm a staff Android engineer working at Vivint Smart Home. I've been building Android apps for more than 9 years now. And I'm also a Google developer expert for Android. I'm also a Google developer group organizer in Boston. So I have my own meetup. I love meeting with people. So I love coding, but I also love meeting with people. And yeah, I live in Boston. Okay, so here's a quick look on the agenda for today. So we're going to learn why performance of the Android app matters and what are some of the quality metrics that you as an engineer need to be aware of. And then we're going to take a look at macro benchmark and micro benchmark that is part of Jetpack Benchmark libraries. And then we're going to wrap up the conversation by talking about Gradle managed devices. So why does performance matter? Now, definitely, if you're dealing with a legacy code base, it is definitely part of a bigger business venture. Now, as business want their app size to grow in terms of user store ranking and whatnot, they would definitely want you to improve the user experience of your app in a way so that more and more users continue to install your app and continue to use it. Now, in today's world where Gen Z and Gen Alpha people are having shorter attention span, anytime your app is slow, they would be having at least 20 different alternatives available in your Play Store. So you do not want your user to go away from your app. Now, if there is a fall in user retention, then definitely the ratings and reviews of your app is going to be affected. Now, here's one of my favorite questions that I like to ask the community. How many of you have seen a review in Play Store with a simple line as, "This app is slow," without mentioning the reason? Right, yeah, not my favorite here. I have been there, and I absolutely hate that. There would be like thousands of reviews saying the app is slow. So as an engineer, it is our job to find out why our app is slow. And we need to find out what are some sort of metrics that qualify our app as slow and where we should start looking for. Because if you don't do that, ultimately, as this slide mentions on point 3, it is going to affect the business metrics. Now, all of those would be much more managed by product management team, where they talk about user retention and engagement and all of those things. So as an engineer, it's our responsibility to take care of all of these metrics. Something to keep in mind that Android launched Jetpack Benchmark testing suite back in probably early 2020. That was an alpha, and it moved to stable version last year in 2022 with a sole purpose, as it is mentioned in the slide, for empowering developers to actively identify and address performance bottlenecks. Because there's a popular saying amongst seasoned Android developer, you cannot improve what you can't measure. So you need to measure first in order to improve something. Now, the Jetpack Benchmark library is divided into 2 categories. So one is macro benchmark, and the second is micro benchmark. Now, they provide all of these individual APIs or library tracking methods which can help you to analyze performance of your app in various dimensions. And depending upon which area of your code base you are inspecting, it comes under 2 categories. It can be a macro or a micro. So let's first take a look at what is macro benchmark. Now, as the name suggests, now I used a pizza analogy over here. Macro is an overall look of your quality metrics of your app. as and when your users are interacting with your app. Now, those metrics could be app startup time, UI interaction. In the old days, like before Compose, we had Recycler View where we had to write thousands of lines. And if you are rendering thousands of items with dynamic images fetched from the internet or including animations, those could be really slow. And the technical term for that is called a jank, a UI jank for non-responsive UIs. So all of those bigger metrics which are directly visible to your user. Now, the macro benchmark library also provides you some sort of API extensions to, I would say, emulate user user actions. For example, if you launch your app and then you want to emulate the behavior of scrolling through a list, or probably clicking on a button that will lead you from screen 1 to screen 2. All of those extensions would be provided in the macro benchmark library. Because essentially, the Jetpack Benchmark test suite is a form of instrumented testing. Now, what do I mean by that? And instrumented testing is a form of testing where you need your app to be launched on a particular device, whether it be a physical device or an emulator. So a little bit of like testing 101. Now, if you're writing unit test cases, you do not necessarily need your app to be executed in an emulator. An individual unit test case can be executed in isolation. But benchmark is an instrumented test case which needs your app to be launched in an emulator in order to measure all of these metrics like startup time and UI interaction and so some sort of like that. Moving along to micro benchmark, considering the pizza and all analogy, it would just represent a slice of pizza, whereas macro benchmark would be the entire pizza. Now, a micro benchmark would be targeting your specific hot functions. Now, we're going to take a look at that later on, what hot functions are, what are critical tasks in day-to-day Android development, and how we can identify them. But these would actually help you to isolate and measure that single most crucial operation in your app. Probably if you are a game developer or someone who is probably building a real-time video streaming application, and you are really concerned about how much time, let's say, I want to say Media 3 library and I want to say Exoplayer, yeah. And so probably you are concerned how much time Exoplayer takes in initializing your video source and streaming content to the user. So all of those can be identified as individual critical tasks, and that can be measured using micro benchmark. And yeah, so it's suitable for complex data structures, computation-heavy algorithms, and repeated UI components, like I gave an example of Exoplayer, which renders frame to frame. It can be also in an iterative manner if you want. Okay. Now let's take a look at how we can get started with benchmark testing in Android Studio. The good news is, starting from Android Giraffe, you can get started with benchmark testing right from the beginning of when you are creating your project. All it takes is right-clicking on your project and selecting new module, and you would see Android Studio comes bundled with this benchmark module type. Now, there would be neat set of options which would be available in this particular screen. Now, on the first row, you would be seeing the different types of benchmark available. So you can select either macro benchmark or micro benchmark. You're going to select your target application. One thing to keep in mind is a benchmark module needs to live alongside your app module. So in a simple way to explain it, your benchmark module kind of latches onto your app module, in other words, the target application, in order to launch it in an emulator or a physical device, and then perform those instrumented tests. Now, you're going to select the target application. You're going to give a module name, anything up to you, the package name, language, obviously Kotlin, the minimum SDK, and the build configuration language. After you click on Create New Module, you would be observing certain changes in your Android Studio project. Now, first thing which you would be observing would be at your app module level build.gradle file, you would be seeing a new build variant. Now, seasoned Android developers would be familiar with different build variant types. So for example, you would be having a debug variant, you would be having a release variant, which you would be releasing it to the Play Store. You would be having probably nightly, one for automation team, one for maybe like separate feature teams. And then after you create a benchmark module, you would be seeing yet another build variant added to your app module automatically. And that's called the benchmark module. Now, these can be customizable depending upon how you have set up your project. The thumb rule, as per Android documentation, is to keep your benchmark variant as close with your release variant. Because as an engineer, we are much more interested in measuring those metrics from an end user perspective. So if you make your benchmark variant much closer to debug variant, a debug app is mostly used by engineers. It is not used by end users. So you would ideally want your benchmark variant to be as close as with the release variant. And that can look in terms of like having the same signing configs. Over here it says debug, but it should be ideally be release. Matching fallbacks, and a lot of customizations depending upon your project type. The second change which you're going to see would be an introduction of a new tag in the manifestation, in the manifest of your target application. Now, this tag is called a profilable tag. What that means is it makes your target application ready to be used by your benchmark module. It makes it ready to be instrumented whenever and wherever we need it. And it got introduced from Android version Q. So over here, that's why it says Q, but it will keep on supporting for future Android versions as well. Moving along. After we have taken a look at the different types of changes introduced in the manifest and the Gradle file, let's take a look at how the structure of the project will look like. Now, we selected macro benchmark, so automatically you would be seeing a package named as macro benchmark, and then you would be seeing an example startup benchmark. All of this is created by default. Now, as an engineer, if you want to create further test cases, you can do the conventional way. That is by right-clicking on the macro benchmark package, clicking on new, and then creating a Kotlin class or a file. Now, before we see the code how a macro benchmark looks like and execute, we need to understand what sort of metrics macro benchmark provides us. So as of today, now it is continuously evolving this library. So we have 4 different types of metrics available. So one is startup time metric, probably the most crucial metric in terms of your business standpoint, a frame timing metric, a trace section metric, and a power section metric. So first, let's talk about how can we measure startup timing metric. Now, in order to measure startup time metric, we need to understand how many different types of startup are there for Android. Now, when someone says, we talked about how reviews are very vague, they say your app is slow. Sometimes they might provide additional information like the app startup is slow. Now, as an engineer, you need to ask which startup, because there are 3 types of official startup provided by Google and the Android team. The first one is called a cold startup. The second one is called a warm startup. And the third one is called a hot startup. So here's a visual representation on how, or how do we describe a cold start. So as the name says, cold start, nothing existed. Maybe the user rebooted the device and launched the app for the first time. So in that case, the Android operating system would be creating the application project from scratch. Within that, it would be initializing the app object, the application class, which we override. And then after the application object has been created, the operating system goes ahead and creates a main thread. And within that, you would be finding different subsections depending upon how many activities you have, activity creation, layout inflation, or composition. And then the initial draw phase is performed. Now, I'm going to talk about the initial draw in a while. Now, how does it differ from a warm start? So, cold start is a case where your app was never launched. Warm start, Now, there is no scientific way of differentiating between a cold start or a warm start. But if you refer Google's Android documentation, the way how they describe it is your app was launched at least once, and there is some sort of residue or remnant existing in your device memory. So probably you launched it and then you backed it out, or probably the device ran out of memory and the OS had to boot out your app out of the memory, and then some sort of residue remained in the app in terms of a process ID or some other memory trim level. So in that case, the operating system does not do much of the heavy lifting. It will simply use the existing application process in your memory and then recreate the main thread. So this entire block of main thread and activity creation, the initial draw phase, would be performed by the OS. Moving along, hot start. Now this is the simplest form of start. All this means is the app is up and running. The user simply backgrounded your app and then brought it again to foreground without exiting out of the app. So in that case, the application process exists, the main thread exists. All the OS does is switching between the application life cycles, so the activity life cycle. So if it was backgrounded, then it would be on stop, and then when you bring it to foreground, it would be on start. Now, in the previous slides, we saw something called as initial draw. Now, these initial draw and full draw is actually termed as time to initial display and time to full display. So when it comes to app startup time, it is further divided into these two metrics. So what does that mean? The name itself tells you, initial and full. Initial would be the user launches your app, and then the very first UI frame that is rendered by your app is considered the initial display. Now, depending upon your app, it might be sufficient to measure just the initial display. But a lot of the times, like 90% of the times, most of the apps would be having a splash screen. And then after the splash screen, there would be tons of data that is downloaded from the internet in the background thread. And then we complete all of those loading and then make the UI ready to be interacted by the user. So that case is called time to full display. So depending upon your app and the scenario and the cases you want to measure, these metrics can be relevant. Moving along to frame timing metrics. Now, frame timing is all about measuring the efficiency of your, I would say, screen rendering performance. Probably like if you have a long composable list or a very complex animation that you are trying to render. Now, depending upon us, how many items you are trying to display to the user or how complex the animation is, the measurement would be divided into terms of frames. Now, there are two metrics for frame timing metrics. That is frame overrun MS, that stands for milliseconds, and frame duration CPU milliseconds. Now, the first one is actually for measuring the time taken whenever a frame misses its deadline. Now, we're going to take a look in the code how it looks like. And the second one is about the amount of time the frame takes to be produced on the CPU on both the UI thread and the render thread. So there is a subtle difference between it, but it will, we can take a look at how it looks like in the code itself. So in the previous slides, we saw that there is a new module created called macro benchmark, and there would be a sample test case already created. Now, over here, I have actually renamed that sample benchmark test case to be base startup benchmark. Now, when you go ahead and create it in your Android Studio, the name might be different. It might be like example startup benchmark and whatnot. But for here, it's important for us to identify the different components of this code. So over here, you can see this base startup benchmark takes an argument called the startup mode. Now, this would be in charge of determining which type of startup we want to measure, a cold, warm, or a hot. Now, we have an annotation get, and this rule is associated with a macro benchmark rule. And that's what we are initializing in the next line, creating a benchmark rule and then initializing the macro benchmark constructor. Now, in the next step, we are writing an actual test case called startup, and then we do an extension method called benchmark rule.measure repeated. Now, this is the beginning of the code where we start measuring the behavior of our app for a given set of parameters. Now, let's take a look what sort of parameters we can add to our measure repeated function. The first thing which is expected is the package name or the target app for which you want to measure the performance metric. It could be a startup time metric or the frame timing metric and other things as well. The next thing would be, just a second, yeah. So we took a look at the package name and then we define the list of metrics. The neat thing of this particular library would be the list of method itself. So if you want, you can give a comma over here and then measure multiple metrics. So right now in this particular slide, I'm just measuring the startup time metric, but we can give a comma and then we can also measure a frame timing metric as well. The next parameter is actually important. So it says iterations, and what that ideally means is how many times you want to execute this benchmark test case. Now, as a thumb rule, you would want to execute your benchmark test cases multiple times. Because when you execute your app, now I already mentioned that a benchmark testing is a form of instrumented testing where you would be launching your app on a physical device or an emulator. Now, if you launch it just once, and then you see good startup times, and you would be happy. And then when you execute after 1 hour, your startup time would be horrible. Why does that happen? Because it depends upon the state in which your emulator or your physical device is in. Probably it was shut down during the last night, and then you switch it on this night. It also depends upon how many apps are running in the background, the available RAM in your device, and all of those metrics. So ideally, the iteration counts can be anywhere between 3 to 10. In my experimentation, I have done max 10 and 3 as well, and sometimes 5. The ideal amount I would recommend between 3 to 5. That would be sufficient enough to get a reliable value. And the next part of this code would be to add a start activity and wait. Now, what it does is we define our target application in the package name. In this case, it's the sample app. Now, when you use start activity and wait, it would be calling the main activity defined in the manifest of your target application. All of these execution would be taken care by the benchmark library by default. It would be launching your app, and then the default activity would be launched by the operating system, and then it will wait for all of the frames to get loaded. And then it can do all of the magical benchmarking related stuff under the hood. Now, in the previous page, I talked about like how we have a parameter for the base startup benchmark where we provide the startup mode. And that is how we can customize it. So depending upon the type of startup mode you want, it could be a cold, a warm, or a hot. You can provide 3 different test classes or test suites, if you may. And then you can provide as arguments. Now, in order to execute your benchmark test case, you would be needing to select the build variant first. Now, in the previous slide, I talked about when you create a benchmark module, how it adds a new benchmark build variant. And this step is about selecting that correct benchmark variant before you execute your test case. You do not want to execute on your debug and release because benchmark module is by default incompatible with your debug and release variants. Probably in future, they may make it compatible, but for now, Google wants us to rely on a very particular variant, and that's called the benchmark variant. Once you select the variant, you can execute your test case in 2 different ways. The first one would be the conventional way of you hover the cursor beside the name of your test class, and then you would be seeing an options for running your benchmark test case in different emulators or physical device. Or the second method would be on the top portion of the Android Studio, you would be selecting the configuration. And then in the list of configuration, you would be seeing the name of your benchmark test case appearing, and then you can select it and then click on run. So for the purposes of this presentation, I ran all of these test cases on the JetSnack app, which is part of the official Compose samples from Google and which is available in GitHub. I'm pretty sure everyone knows about this sample, but for sake of simplicity, I added the link for it. Now, when you go ahead and you execute your benchmark test case, this is how the results will look like. Now, it is important for us to understand how to interpret from these kind of results. So on the side pane, you can see the test results. This would be having different sections depending upon how many test cases you have created as part of your test suite. And then on the bottom, you would be seeing the actual test results. We can ignore all of these tasks. Now, we want to focus on this particular section on the bottom, which is inside the red rectangle. So you can see two different metrics being measured. The first one is time to full display, and then the second one is time to initial display. And there's also a minimum, a median, and a max, which is calculated depending upon how many iterations you are providing. So in my experimentation, I provided 5 iterations, and these are the results. Now, as an engineer, it is definitely up to you and your team how rigorously you want to monitor your performance. Maybe you are like absolutely strict about performance, so you would be relying on the max time and you would be seeing like, no, 930 milliseconds is way too high for time to full display. Or if you are okay with performance being like a little bit on the average side, so you can rely on the median results over here. Now, I told this earlier, but all of these results depend upon the type of device or the emulator which you are using, how powerful it is, what type of system version it is running, what sort of apps are running in the background, and all of those things. A similar result for the frame timing metrics. So these would be in terms of positive or a negative value for frame duration, CPU, and frame overrun milliseconds. Now, the frame timing metric outputs all of these things into sort of like percentiles. The P stands for percentile, and these would be in terms of 50th, 90th, 95th, and 99th percentile. And also something to keep in mind is starting from Android 12, it also returns how much time your frames were over the limit, which is for frame overrun milliseconds. Now, I haven't experimented with benchmark testing below Android 12, but from what I gathered from the documentation, frame timing metric can be unreliable if you are running your target application on Android 11 or lower. Now, that is not applicable for the startup time metric. Startup time metric should be applicable for lower versions of your Android app as well. Okay, now let's move along to the trace section metrics. So we talked about the overall measurement of your performance in terms of startup time and frame time. But what if, as an engineer, you want to measure a particular critical task within your code base? Now, how do you identify a critical task? Well, the short answer is it's up to your business use case what you identify as a critical task. Now, here are a few examples. Now, from a development standpoint, we use a lot of libraries, probably Lake Canary, Firebase, dependency injection libraries and whatnot. So if you have tons of libraries in being initialized in your application class or during app initialization, that could be considered as a critical task. If probably you are using a browser app, maybe the time when you launch your app, you are spending some time on restoring downloads, or probably a simple example would be rendering a list in terms of recycler view or a composable list. So let's take an example of the rendering list functionality for a second. Now here's an example composable code which renders a list called as collection list. And pretty much basic code. It has a box layout, and within that lazy column, it doesn't matter how you are initializing your composable. All that matters is we would be initializing a new statement in our code, and that is trace list composition. And once you do that and you execute your benchmark test case, you would be seeing the trace name of of that particular code being displayed in the results section. Now, moving along to the micro benchmark metrics. Now, previously I showed trace section metrics, which also does a similar thing as micro benchmark metrics. Something to keep in mind is trace section metrics is still mentioned as experimental as part of the Jetpack Benchmark library. Probably the Google team or the Android team is evaluating whether to go through the path of trace section metrics or micro benchmark metrics. But overall, micro benchmark metrics and trace section metrics do kind of a similar job. Now, micro benchmark metrics can also help you in measuring those individual critical tasks in your application. For example, image loading performance, recycler view performance, network calls, and example like restoring downloads and rendering of text and along those lines. So here's an example of a sample code which kind of loads an image from a source and generates bitmap pixels through it. Now, you may say that as a seasoned Android developer, we are using many libraries which do the same, like Glide and whatnot. But a lot of game development application developers try to do similar kind of operation from scratch only because they want to make it optimized for their case. And also think about in cases where you want to develop a library similar to Glide. So if you want to do that, you would need to perform these kind of operations like dealing with complex bitmap pixels and all of those things. So in the sample code, I have created a class called bitmap benchmark, and then it follows the same rule. We do a @get annotation for micro benchmark test case, and then there's a sample variable which determines the source of the image. It could be in any of the sources, like it could be in a database or a room, or probably you're downloading from network. And then we define a context which is important for, oops, it went on to the next slide. Yeah. So we define a context where it is important for us to get those instrumentation metrics for that particular micro benchmark test case. And then after defining the source of the image, we declare a bitmap variable, which utilizes the context described on the previous step. And then we kind of use a bitmap factory for decoding those streams of bits that is being read from the image location. Now, how will our test case look like? It will look like something like this. So for example, I want to create a test case where it reads or fetches a row of pixel, one pixel at a time. And that is what this code does over here. There's a pixels variable, and there's a 100 cross 100 array being initialized. And similar logic as we see in macro benchmark library, we use a measure repeated, and then it fetches a row of pixel one at a time. And there is another test case where I want to fetch a row of 100 pixels at the same time, and I do not want to read it one pixel at a time. So considering these two examples, if I execute my micro benchmark library, the results will look something like this. You can see over here, there would be two different sections for the measurement. The first one would be for get 1 pixel benchmark, and the second one would be for bitmap get row pixels benchmark. Now the metric would be over here is how many ALEX. ALEX is like a unit of memory management, or like blocks of memory that is being utilized. Now, back in the days of like lower level programming, like C and whatnot, where we used to do a lot of custom memory allocation, all of these terms were relevant. These days in Kotlin and Java, we do not take these kind of metrics into consideration. But when you're building a library like Glide and all of those things, these lower level of metrics go into a lot of consideration when you want to improve the performance of your app. So this was an overview of how you can measure individual critical tasks in your app code base. Now, I already talked about executing an instrumented test case using emulator and a device. So the next step would be when you want to execute or have a benchmark testing suite in your code base, you would ideally want all of those test cases to be executed in a consistent manner for all of your releases. And if you rely on different devices or emulator for every single release, then you would be losing the importance of the improvement of your performance metrics down the line. And it would be very difficult to represent all of these values to business people and talk through the journey of how you have improved your performance. So it definitely makes sense for us to rely on a consistent emulator on which we can rely on from release to release. And that is what Gradle managed devices provide us the capability for. So Gradle managed devices are definitely emulators, which can be configured in the build.gradle file in your code base. They provide environment consistency and also the test execution management. So it is all about customization on the environment on which you want your benchmark test cases to be executed. So how do we do it? It's pretty simple. Now, on the benchmark module level Gradle file, you have to create a test options section. And within that, there would be a manage devices section. And inside that, you would be finding all of these by default device configurations available in Android Studio. Now, these device configurations or the profiles are the ones which come bundled with your Android Studio. I think right now, Android Studio provides us with Pixel 6. I don't think there is a support for Pixel 7 yet. But as and when Android Studio adds new emulator configuration or device profiles, those would be available in this device configuration. And you can provide them as a Gradle managed device. So whenever you execute your benchmark test suite, every single time your test cases would be executed on a set of specific devices, so that you as an engineer would be empowered to make rational analysis of the results that you are seeing from a release to a release. And here's a quick summary of what we learned. So we learned that Jetpack Benchmark is definitely a very effective tool for monitoring performance and measuring performance from an engineering standpoint. Now, you might say that all of these metrics like startup time and frame timing are already available in Play Console and Firebase. But my argument is most of the time as an engineer, when you are performing optimizations on the go, you would want a reliable method of measuring those metrics in a local environment rather than relying on network calls or probably pushing your app to production and then seeing what is the improvement. So it's all about development productivity, if you may say that. Yeah. And so yeah, Jetpack benchmark libraries are categorized into two different sections, macro and micro. And we can definitely monitor performance on our code base by integrating all of these benchmark test cases suites to our CI process, Jenkins, and whatnot. We can also leverage Gradle managed devices in order to provide a consistent measuring mechanism. And yeah, that's it. Feel free to connect me in LinkedIn, and then I also write performance engineering blogs in Medium, so feel free to read those. And if you are ever in Boston, then definitely come to my meetup and say hello. And thank you.